Welcome back to the Python Praxis. In today's session, we'll explore one of the most fundamental yet powerful concepts in Python programming: variables and data types. By the end of this lesson, you'll be able to store, process, and manipulate information efficiently in your Python code. In this lesson, we'll cover two main topics. First, we'll dive deep into variables, including integers, real numbers, also known as floats, strings, and booleans. Then, we'll look at type conversion, how we can smoothly convert from one data type to another. Ready to jump in? Let's go. Every program you've ever seen has three simple parts. It stores information, processes it, and produces results. To store information, we use variables. Think of a variable like a labeled container. You put data into it, label it clearly, and then easily retrieve it whenever you need it again. In Python, each variable has two key things: a name and a type. The name is how you refer to it, and the type is automatically assigned based on the value you put inside it. Just keep in mind, names are case sensitive. So, my data and my data are considered two completely different things. For clarity, always choose descriptive names like user age, and if your variable has multiple words, use underscores. Python variables mainly store four basic data types: strings for text, like hello; integers for whole numbers like 42; floats for numbers with decimals like 3.14; and booleans for logic-based values, true or false. To create a variable, just use the equals sign like this: variable name equals value. Simple, right? Let's put this into practice with some examples. Here's an integer: year equals 2005. For floats, we can do calculations like price is 19.99, tax is 2.50, then calculate total, price plus tax. Boolean values are straightforward: is admin equals true. And finally, strings store text, like this greeting. Greeting equals welcome to Python. Now let's talk specifically about integers. Integers represent whole numbers. They're ideal for counting, indexing, or looping. Interestingly, Python can handle integers of virtually unlimited size, so you'll never run out of room. In Python, we can perform basic arithmetic with integers, like addition, subtraction, multiplication, and division. We also have special operators, such as integer division symbolized with two forward slashes, remainder of integer division called modulo, and symbolized with %, and exponentiation ***. Just remember, regular division will always give you a float, even if you divide two integers. Imagine you wrote a book with 95 pages divided into 8 chapters. How many pages would each chapter have, and would there be leftover pages? Let's check. We have 95 pages and 8 chapters. So average pages equals pages integer division chapters. Leftover equal pages modulo chapters. And then print pages per chapter and leftover pages. Python neatly gives us the answer. Here's another scenario. A robot consumes 7 energy units per hour. We want to find out how much energy it uses in 5 hours, and then see what happens if we square that number. Energy per hour equals 7, and it works for 5 hours. So total equals energy per hour times hours. And boosted equals total to the power of 2. Then prints squared energy in boost mode. Now we know both. When Python evaluates expressions, it follows a specific order, just like in mathematics. First powers, then multiplication, division, and finally addition or subtraction. Parentheses let you change this order. Here's a quick practice. Pause the video and try to guess the results of these expressions before running the code. It'll sharpen your Python instincts. Floats, or floating point numbers, are simply numbers with decimal points. We use floats whenever we need precise measurements, such as calculating money or scientific data. Notice the difference. 5 is an integer, while 5.0 is a float. The arithmetic we performed with integers works similarly with floats: addition, subtraction, multiplication, and more. The only difference is that the results are always floats, ensuring precision. Python gives us handy shortcuts for updating float values, like plus equals to add quickly. For example, we have balance equals 10.0, and then balance plus equal 2.5, which is the same as balance equals balance plus 2.5. Simple and effective. Let's see this in action with temperature adjustments and currency conversions. To increase temperature slightly, we use plus equals. For currency conversions, multiply by an exchange rate. Keep in mind, though, that floats sometimes have tiny precision errors. Don't panic if you see unexpected decimals. Here's a quick task. A customer buys rice, cheese, and sauce. Let's calculate their total weight in grams. Rice in kilograms equals 1.2. Cheese in grams equals 450. Sauce in grams equals 330. So total weight equals rice in kilograms times 1,000 plus cheese in grams plus sauce in grams. Then prints total weight in grams. Your small grocery scale tool is ready. Fantastic! You've just unlocked some of Python's most powerful concepts: variables, integers, floats, and arithmetic operations. You've learned how to store data efficiently, manipulate numbers easily, and even dipped your toes into practical examples like calculating chapter pages and grocery weights. You should feel proud. You're well on your way to mastering Python fundamentals. But Python has much more in store for us. In our next lesson, we'll continue our journey by exploring strings, perfect for handling text, booleans, essential for making smart logical decisions, and we'll also dive into the magic of type conversion, empowering you to seamlessly transform one data type into another. Trust me, the adventure is just beginning, and the best is yet to come. Thank you so much for learning with the Python Praxis. Take a quick break, recharge, and I'll meet you in the next video. See you there. XT time, happy coding!